Good morning, everyone. Once again, previous class we have discussed about flyback converter. Basically, in flyback converter, there are two types of flyback converters. One is discontinuous flyback converter, and this is the continuous flyback converters. Previous class, we have discussed about the discontinuous flyback converter, where it's going to work in three different modes. Mode 1, Mode 2, Mode 3. Mode 1, in that one, the diagram says that the transistor which is connected to the primary windings, the transistor or the thyristor or the switch which is connected to the primary winding is closed, that is on. At that time, the diode which is connected to the secondary is off. The problem here is two windings what we are having, primary winding and secondary winding, they are in opposite direction. The current flows in opposite direction because the dot indicates that one where exactly your polarity comes into picture. So here, listen, here, even though I am giving the DC power supply, I am having a transistor which is kept here, the switch is closed, the switch is on, and the primary winding, the current flows here. Since the secondary winding is in the reverse direction and the diode is in reverse bias, diode is in reverse bias, that is mode 1. Mode 1, secondary winding is in reverse operation, so diode will be in reverse bias, diode is going to get open. So mode 1 is one operation what we are going to get. In mode 2, that is mode 2, where the transistor or the thyristor or the switch which is connected to the primary windings which is open, when it is open, there is no current flows. Previously current flows, when the switch is closed, previously the current was flowing inside the primary winding, that is getting charged over there. But when the switch is open, the current flowing is stops over there. At that time, the secondary winding which is connected, it's going to be in reverse bias, and it's going to conduct the diode over there. So that is mode 2. When the switch turns off, the current in the primary windings drops suddenly, the voltage across the primary winding reverses, the diode becomes the forward bias. That means the voltage, since it is becoming the reverse bias, the secondary winding, it's going to be in reverse operation. What it was working previously, totally it's going to be in the opposite direction, so that the diode will be in the forward bias, it's going to conduct over there. So that is what we are having. EDC we have written in the previous class, EDC, and it's going to conduct with respect to T1 and T2, and T2 and T3 also is going to conduct over there. This is mode 3. The mode 3 operation where switch is also open, diode is also open. Switch is also open, diode is also open. During discontinuous mode, the MOSFET is also off, diode is also off. The output capacitor continues to supply uninterrupted voltage to the load because previously in the mode 1 only switch is on, diode is off. Okay, only primary winding it is charged. Secondary is not working, it's in the reverse bias. But in the second mode, the mode 2, primary windings it is discharging over there because of the reverse bias over there. Because it is discharging, the secondary winding is getting conducting, and through the diode sending the data. Load is getting the output. When load is getting the output, we are having a capacitor. Capacitor is also getting charged over there. When the third mode comes into picture, switch is also open, diode is also open. Since in the previous mode the capacitor is charged over there, that is getting discharged as of now. When the capacitor is discharging, that will send the power supply to your load. So load, we can able to measure the load voltage across the diode. So these are the three different modes what we are going to have in discontinuous mode of operation of your flyback converter. Mode 1, mode 2, mode 3. So if there is a question, already framed some around 30 questions. I think you might have got some information regarding the IA. Any subject teacher have go to that? It will be surprise for me. I'm not sure. It might be a little one. There may be different set of question papers will be generated. For the same subject. So, everyone will not get the same question paper. Whatever topics we are going to cover, don't omit anything, don't repeat anything. Everything you should read compulsorily. The person already and no, that is their own to manage. Easy and tough will not come over. It is easy if you are studying something easy class, it slow it down. So this is one small information I am going to give you. So whatever I am covering, then only I am going to present the questions. Kindly read them. And I already told you problems with them, solve problems. I am solving itself. I am giving you that. And with that, I am going to give you by Sunday. Everything will be ready this Sunday. Okay. So with this information, we'll move ahead with the next topic. That is. So mode 3, the applications, there are so many applications are there. It is because of flyback discontinuous mode. It's a low cost, low power. It's useful for more low power. Low cost has no output inductor and cheap output diode. Diode is a small value, cheap value we are going to use in this particular discontinuous mode of converter, and we are not using any inductor over there. Inductance is not required. That is one of the advantage. And major disadvantage is output spike at turn off. Output is going to spike. Large filter capacitor is going to be used. These are the two disadvantages. Even yesterday's class I told you that. Next topic, that is today's topic. The other type of flyback converter. Till now what we have discussed is discontinuous mode only we have discussed. Discontinuous flyback converter. Now we have to go for continuous flyback converter. There should be a continuous supply. We have almost, it looks similar to the previous diagram only. Almost. Any difference you are able to see? Yes? Yeah. An inductor is going to be used here. Previously, we were not using the inductor. That is the discontinuous mode. That is the advantage of the discontinuous mode where inductor was not using. But in continuous mode, we are using the inductor at the secondary. Primary is same as the previous mode. Primary, we are not touching anything. But in the secondary, we are adding the inductor. The inductor is getting charged and is going to give the supply. So that's why we'll call it a continuous mode of operation. So here, the continuous mode of operation, the circuit is almost similar to the discontinuous, but energy is stored in the core is completely transferred to the load. Circuit is almost same as that of discontinuous mode. Flyback converter, but an inductor or inductance is added at secondary winding. This one addition with respect to your continuous mode of flyback converter. Since it's a secondary winding is there, we are having the entire energy is transferred to the load. The energy stored in the core is completely transferred to the load. when, and so the transmission will be on. The statement which is given is the major difference between your discontinuous and continuous is one is the inductor at the secondary. Because of the inductor is secondary is there, the continuous, whatever the energy which is storing in the primary winding, whatever the energy which is storing in the secondary winding, they are going to be transferred to the load. Since it is continuously it's working, the Q1 is also working continuously. The flyback converter operates in continuous condition if converter is operating on full load and if the supply voltage is minimum. That is also one point. It will be continuous mode if supply voltage is minimum and with full load. So I am writing just a simple sentences. In the textbook they are given a sentence which is lengthy. I am just writing point by point over. First of all, the system is continuous. Forward bias, reverse bias, whatever you want to call it, is not working here. Whatever the EDC they are applying, that will go and store in the primary winding. You ask the transistor is on, and since it is reverse bias, we are checking it over there. But since it is reverse bias, initially it will not conduct. But once you go for switching off, when you go for switching off, immediately secondary winding is going to work. That will store the energy in the inductor, and inductor is taking care of continuously sending the data, continuously sending the supply voltage to the load voltage. So the major advantage here is behind the inductor. This will store the energy, and this energy will be continuously keep on sending to the load over there. IL is keep on coming over. Previously, we were in the part of this capacitor, but now since we have included the inductor, this will take care of continuous operation. Whatever the energy was there, it's going to continue. Since it is continuing, the switch, the mode 1, mode 0, mode 2 will not be working over there. It continuously works. Okay. So, what are the applications we are going to have with respect to continuous mode? Generally, I told you computers is going to use printers, this type of continuous playback converters will be used, and TVs. Computers, printers, TVs, everywhere we are going to use the continuous playback converters where continuously we need to have a supply voltage to the load. The voltage should appear in the load itself. What are the load you are going to give? It should supply. See the difference with the waveform. Previously, the waveform what we are having, it was starting from 0, the current, and setting at 0. When you look into the previous waveform, discontinuous waveform, the primary current, the secondary current, it was starting from 0 and ending here. It's ending to 0. But here it is not like that. The primary current initially will be having some value based on the input voltage, and even though it's reaching 0, it will once again come back to some initial position. It's going to continue over there. See here, the primary current initially only it's having some value, and even though it's coming down to 0, once again it will start from the each time. That is T on time, Q on time, and Q off time. Q on time, Q off time. Q on time is also having some input initial current, and Q off time also will be having some input current over that. That is diode current. This is your primary current, this is the diode current. Primary current is increasing, and during the T of time, diode is keep on decreasing over there. The voltage, the current across the diode is keep on decreasing. Finally, we are going to get a converter. It's going to convert like this, and the phase, the maximum phase will be in the as similar to that of your IP, that is primary current and also diode current. So this is the major difference between your discontinuous mode converter, playback converter, and also continuous mode playback converter. Based on this, we can come to a conclusion that there are some advantages of